Section 3.9 is where we're at. And before we really talk about what we're doing here, let's review a little problem here. Let's say y equals, I don't know, 4x squared plus 3x plus 5. Okay? What is the derivative? What's y prime? 8x plus 3, right? Okay. What we're going to do in this section is basically do that backwards. Okay, so we're going to start with something like this. Y equals 4x plus 2. And we're going to say, what is the, that's y prime. What is y? What is that the derivative of? 2x squared plus 2x.
But then don't you always have like a plus 7 or
Oh, okay. So let's come back to that. First of all, what this is called, what we're doing is taking the antiderivative. Okay. So you can sort of think of it as the inverse of taking a derivative, or the opposite of taking a derivative, or undoing a derivative, or something like that, right? So you're given a derivative, and you have to find the equation that this equation you were given is the derivative of, right? Finding the antiderivative. Now this is a good point that was brought up, because if here we have y equals 4x squared plus 3x plus 5. What if that was plus 20, right? Would that change our answer? No, right? Or we could add any constant we want in there, right? In addition, like what we can do with these, when we get the antiderivative, like 2x squared plus 2x, what we do to check our work is you take the derivative of it, and if the derivative is the problem you were given, great, right? So in this case, it works. 2 times 2 is 4, and the 2 stays, and so it looks good. But we could take the derivative to, if we, put plus 4 there, right? We take the derivative, we still get the correct function. Or we could add any constant, right? So how do we take care of that? Close the door for me, Nathan. Or Emilio. And why? So obviously we can add any constant. When we take the antiderivative, we can put any constant in there, and it still works. So how many antiderivatives are there possible for any given problem? Infinite, right? And it makes sense, if you think about it. The derivative of a constant is 0, and so it's always going to end up being the same. But it makes sense visually if you do this as well. If you take that equation, 4x squared plus 3x plus 5, right? It looks like some parabola, right? I don't know what it really looks like. It may be somewhere totally different or look something different. But it's some sort of parabola like that, right? We'll say that's 4x squared plus 3x plus 5. What if I took the same equation and I added 5 to it or whatever? So it was 4x squared plus 3x plus 10. It would just be up here, right? Okay. When we find the derivative, right, which we have there, the 8x plus 3, what does that tell us? What physical aspect of the graph does that give us for the original equation? Rate of change, and we also call that, what do we call that in a physical sense? Velocity, that's in relation to if this was displacement, then velocity. I heard it. Slope, yeah, it's the slope. The derivative gives you the slope of the original equation, right? So if we have here 2 options for the original equation, right? And all we're doing is moving it up, right? So if you take any particular x value, like right here, right? You have a particular slope right there, right? Well, if all you did was move it up, the slope is going to be the exact same thing there as well, right? So there's an infinite number of equations. You can move this up or down as much as you wanted, and you still get the same slope at any particular point. So there's an infinite number of equations that have the same derivative. Or in other words, any equation you have has an infinite number of antiderivatives. In this case, it's 8x plus 3. It has an infinite number of antiderivatives. Same with 2x plus 2. It has an infinite number of antiderivatives. So instead of just throwing a 4 in there, we can't really do that because we don't know, there's no reason for doing that. We'll look pretty soon at situations where we can't put actual numbers. But instead of putting a particular number there, what should we put to represent the infinite number of options that we have? Okay, yeah, C, right? For what? Constant. Yeah, C is a letter. It's like a variable, but it represents a constant. It just says that any constant can go there and it still works as the antiderivative. When we do that, we call that the general form. General equation. General equation of the antiderivative. Basically, that just means we have the plus C on there. Okay? The plus C is very important. If you don't have the plus C, the problem is incorrect. So on quizzes and tests, if I ask you to take the antiderivative and don't give you a reason to put an actual number there, then you need the plus C. Okay? You always, always, always need the plus C. It's basically the equation for the antiderivative with a plus C at the end instead of a constant. Okay? You always need the plus C. The only time you don't need a plus C is if you actually know what C is. Okay? So now we'll look at a situation where we can actually find the plus C. So that was the general equation. Let's see. And if you have an actual number for C, what you get is the particular equation. So that's what we'll do now. So you start the same way. You'll start with something like f prime of x equals, let's see, we'll do 15x squared plus 4x plus 2. Okay? But in order to find the particular equation, you need a little more information. And so in problems where you'll be asked to find the particular equation, you'll also be given what's called an initial condition. Okay? An initial condition looks something like this. F of, let's say, 2 equals, 40. Okay? F of 2 equals 40. That's our initial condition. And that's what we're going to use to find the particular equation. The first step, though, is to find the general equation like normal. So if f prime of x equals 15x squared plus 4x plus 2, what is f of x? Yeah, it's going to be x cubed. And there's going to be 5 here, so that when the 5 and the 3 multiply, we get the 15. Plus 2x squared again. This is basically like our last one, plus 2x, plus c, right? We need the plus c. Always need the plus c. And then we can use that to find the particular equation because we know that f of 2 equals 40. So we can say 40 equals 5 times 2 cubed plus 2 times 2 squared plus 2 times 2 plus c. So 2 cubed is 8 times 5 is 40. 2 squared is 4 times 2 is 8. 2 times 2 is 4 plus c. So 40 plus 8 plus 4, which is 52, equals 40. So if 40 equals 52 plus c, then what is c? Yeah, c equals negative 12. Okay? Now we take that and we can plug it in to our general equation to get the particular equation. I'm just going to move this all up so I have some room below. It's still going to be there. Well, you can get a new piece of paper. Okay, so we're going to get f of x equals, and we just put in the general equation, 5x cubed plus 2x squared plus 2x plus, but instead of plus, what should I do? Minus 12. And that's our particular equation. Okay?
So when you have the initial condition, you do the equation.
Okay, let's make a rule for the power rule. You need another minute? Okay, let's make a rule for, well, we'll just kind of apply the power rule for antiderivatives. So we'll say if y prime equals x to the n, then y equals what? What do we do with the n? What do we do with the exponent? We add 1, right? So the new exponent is going to be n plus 1. And what do we do in front? If we go back to this one, or let's actually go back even further. No, let's go back to this one again. The 15, how do we get 5 from 15? Right? We divided by 3, right? We divided the 15 by 3. Right? So 3 is our new exponent, which is n plus 1. So we have to multiply by 1 over n plus 1. Or, in other words, divide by n plus 1, right? Okay. So let's see if f prime of x equals 20x to the 4th, then f of x equals what? It's going to be x to the, it's going to be to the 5th, and so we divide 20 by 5 and we get 4. Are we done? What's the last part? Plus c. Okay, what if f prime of x equals x to the 9th? F of x is? It's going to be x to the 10th, 1/10. Then what? Plus c. Okay. Okay. Some other rules. If remember, if I'm just gonna, I'll go back to that last page in a second. But if y equals sine of x, y prime is what? Cosine of x, right? So what's the antiderivative of cosine? No. Antiderivative of cosine is sine. Yeah. What if y equals cosine of x? Y prime is negative sine, right? So what's the antiderivative of sine? Yeah, negative cosine. Yeah. If y prime equals sine of x, then y equals negative cosine. So if you think about it, you take the derivative of cosine, it's negative sine, and this negative cancels it out to make it positive. Okay? In fact, I will pause and end the video. Goodbye, YouTubers.